So as usual, we can see this is from chapter 2, section 4, because of the label at the upper screen. In fact, that's something that I can write on here. So up here, we can always see the label of where the problem comes from. So question 5 is from chapter 2, section 4. It's actually problem number 17 from the test bank set. And the task is to solve the triangle. And so they give us this triangle here on the right. And on the triangle, we can see that they've given us this side length here. So this is side B because it's opposite of angle B. And they also give us angle B as well at 45 degrees. And we're supposed to, and of course we know there's a angle C is a right angle. And we're supposed to find everything else. And in each answer that we're supposed to find, it says round to a particular place, round to 4 decimals, 3 decimals, 3 decimals, not all to the same place. Okay, so now how would we go about this? Well, in this case, what they've given us is 2 angles and 1 side length. And so in the first goal here is to find angle A, which is this angle up here in the triangle. And anytime you have 2 angles in a triangle, you can find the third because all 3 add up to 180 degrees. And in this case, we know one of them is 90, so the other 2 have to add up to 90 degrees. So I know that A plus the angle that they gave for B is 45.0898 degrees. That those have to add up to 90 degrees because those are the 2 acute angles in a right triangle there. All right, so knowing that, I can subtract 45.0898 from both sides, and that's going to give me the missing A. So I guess I would do that on a calculator just because the decimal is big enough. So I'm hopping over to Desmos on my other screen, which I'm not showing, but I'm gonna type in here. I think I can do that. Well, we're gonna get 44 point something. So I'm gonna get A is equal to 90 minus 45.0898. And so I'm just doing this on a calculator. I have 90 minus 45.0898. So I get that this is 44.9102. And again, these are in degrees. And so then I take that answer and I look at where I'm supposed to round. It says to round to 4 decimal places as needed. But that's where my answer comes out to because they gave me this to 4 decimals. So this is the answer I would put in there. So I'm going back to the screen where we can see that. And so I want to put in 44.9102. So then for the next part, I want to get the other 2 sides. So let's see here. Yeah. Whoops. Where's my, all right, well, I'll just do that with a separate screen. Okay, so now to get side, we want to get side A, which is here on the bottom, and we want to get side C. Those are the 2 sides that we have to fill in. And so we have both angles, but just using the one they gave me already, that's angle B, then side A is the adjacent to side B angle, and side C is the hypotenuse. So when I have the adjacent and the hypotenuse, which trig function would that tell me I should use?
Cosine.
Cosine, right? So ka, the ka, C-A-H, so that's cosine of an angle is equal to the adjacent divided by the hypotenuse. So that's going to tell me that cosine of angle B, which is 45.0898 degrees, is going to be equal to the A value, which is the adjacent, divided by the, oh, I just totally screwed that up. We don't know either A or H. Those are the two things we want to find out. We have to have it where we know two of the three things here. So instead of using the hypotenuse, I need to use the opposite because that's the side we know. Silly me. Someone may have tried to point that out in chat if I didn't notice. So actually, I need to draw back on that. Instead, we want to use the A side, the adjacent, and we want to use the opposite side because we know the opposite side, but we don't know the adjacent side to the angle. And so that means we need to use the tangent for the TOA, except I just got it reversed. All right, I'm messing this up. All right, so we want to use the fact that the tangent of the B angle, 45.0898 degrees, is equal to the opposite side of the angle, which we know, 57.855 centimeters, divided by the adjacent side, A, which we don't know. Let's see here. Let's clean this up with some of my false start erased here. All right, so we know angle B, and then we have the opposite to angle B, and then we have adjacent to angle B, and tan is opposite over adjacent. So tan of the angle 45 gives me the opposite length over the side we want. Now we want to solve for A, so I would multiply both sides by A, or move the A over to the other side that way. And then I would divide both sides by the tan. And so over here I will get the tan of the angle, 45, etc. And so that's going to give me what I want to put on my calculator. I want to put that A is equal, because this cancels out. So A is going to be equal to 57.855 centimeters divided by the tan of 45 degrees, or 45.0898 degrees. And so that will give me A. So I'm going to do that over here on my calculator. So I've got 57.855 divided by 45.0898. Take the tan of that and then do the division. So I ended up with pretty close, actually. I got this coming out to be 57.6739307307, some, way more decimals than I need. But I'm supposed to round this to 3 decimal places. So if I look at the first 3 decimal places, and I see there's a 9 in the 4th decimal place there. So then I'm going to actually say that A is approximately equal to 57.674. So I'm going to go back and put that answer in, but before I do, let's pause here because I kind of made a big mess. Any questions about how I came up with side A there? Okay, I don't see anything in the chat either. All right, so let's see if I can put this in. So I'm going to go back to off of my tablet here and go back to the problem. And so we want to go into this answer here, and I want to put in 57.674. All right, so then finally we want to get C. So we could get C in a similar way. And to get C, then I would be using the opposite of that angle, which I know, So to get C, now if I'm just using the fresh problem, this is the opposite to angle B, and this is the hypotenuse. And so the sine is opposite over hypotenuse. So that would tell me that sine of 45.0898 degrees is equal to 57.855 centimeters divided by the hypotenuse. And then I could solve that for the hypotenuse. Or since we now know two sides, we could use the side that we got for side A and the Pythagorean theorem to get the hypotenuse. But we'll just stick to what we have on the screen here. Okay, so again, kind of like before, I would move h to the left and divide by sine, and I would get then that the hypotenuse is equal to 57855 centimeters divided by the sine of the angle, 45.0898 degrees. Questions about how I solved for h and got something to stick on my calculator to try to get an answer? All right, so let me see if I can do that over here. So I'm going to have 57.855 divided by 898 with a sine of this angle. And I get that h is approximately equal to 81.691. I'm supposed to round this to 3 decimal places, and after the 1 is a 3. So 81.691 when rounded to 3 decimals. So I'm going to put that in. Not 89, 81. 81.691. So hopefully I didn't make a mistake there. Let's see. So that was how we solved for this triangle in problem 5 on the practice problem set for section 4. Questions?
I have a question.
Yeah, go ahead.
So if you already have two sides and you use the Pythagorean theorem with numbers that have decimals to that place, will it still work, or do you have to use this method?
No, Pythagorean theorem should also give you the same answer.
Okay, thank you.
Yeah. Other questions at all? All right, so that was number 5. It's like 23. Let's try maybe number 10. So go 5 more problems in. So this looks kind of similar. In this case, they're asking us to get, I don't think we need that. It says solve the right triangle, where they give us a C is a 90 degrees. That's why it's a right triangle, and give angles in degrees and minutes, and they give us 2 of the sides. All right, so in this case, they didn't give us a picture. So let's say we try to begin this problem. Whoops, I can use that. And that just cut off the beginning of the problem, it looks like. That's kind of interesting. Let's try that again. Just cut off here. There we go. Now let's do that. Okay. All right, so if I try to draw this triangle and maybe use a better color. So we have a right angle, and that's C. So the hypotenuse would be little c, and they have a 19 and a 23. And so they're telling us that 23 meters is C. So C is equal to 23. And then A is 19. So I'm just going to say this is A down here, and that's angle A. And this is angle B, and that's B over here. So we know that that's 23, and we know that A is 19. All right, so what did they give us in this case? Instead of giving us two angles, they only gave us one. They only gave us the 90-degree angle. And instead of giving us one side, they gave us two sides. So we could find the third side immediately by using the Pythagorean theorem, not caring about the angles at all. And that is the first thing they ask us to find, is the approximate length of side B, which they want us to round to the nearest whole number as needed. So this maybe sounds kind of like the problem that somebody was asking about in the beginning, where we're calculating a side and rounding that to the nearest whole number, and then maybe that'll make it harder to find A or B. I don't know. But in any event, so let's begin by trying to find B. So to find B, we know that A squared plus B squared equals C squared. And as I said those, I filled in the two that we know. So if I solve this for B, that means B will be equal to the square root of 23 squared minus 19 squared. I subtract B squared from both sides. Sorry, that's exactly wrong. I subtract 19 squared from both sides to make those go away, and then I square root to get rid of the square, and that's how I end up with this. And so then I put that on a calculator and see what I get. So I'm going to have 23 squared minus 19, which is also squared. And then when I get that, I'm going to take a square root, and I end up getting approximately for B 12.96, and then some other stuff, 1, 4, 8, blah, 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 blah. So to round this off to the nearest whole number, we would say that that's approximately 13. So I can bounce back here, go into there, put in a 13. All right, so then they want these angles A and B round to the nearest minute as needed. Now, is there any way I can get back my picture? Sorry, I'm still figuring out how to do some of these things. Maybe if I go here, is it somewhere? I don't even know where it is. I don't see it. I think I just get a new one. Oh, well, I'm not sure how to get back to the other one. Probably a way to do it, but again, I'm still a little new to some of these things. All right, so what was our picture like? Quick and crappy. We had a right triangle. We have given that this is 23. We have given that this is 19. So that's A. So this is side A, and then we have B here. And we just got the B is approximately equal to 13.
Yes, that's what we got. We also have the equation of 19 squared plus B squared plus 23 squared. Then we subtracted 19 from both sides.
Oh yeah, well, I'm actually not going to rewrite that stuff. I just wanted to get my triangle back because that's how we figured out B, and now we already know.
Okay.
So yeah, I wanted to get my triangle back, and I was going to erase that other stuff. So this is just as good. All right, so now the question is, how do we get A and B? Well, what I would do is I would use the sides that they gave me to get those missing angles. And one of the things we looked at in the earlier sections was when you're trying to use an angle and you know the ratio of the trig function, then you can use the inverse function to get that. So for example, I know looking at angle A, which is the first one they ask for, looking at angle A, I can see that the known side of 19 is opposite to that. And the hypotenuse is 23, and opposite over hypotenuse is sine. So I know that sine of angle A is equal to the side that's opposite angle A divided by the hypotenuse, and those we were given in the problem originally. And so when you know what the sine gives you and you want to know what the angle is in the 0 to 90 degree range, then you can find the angle by taking the inverse sine of that value. So that's what I would want to put on the calculator. When I do that on the calculator, it's going to give me something that's kind of in a decimal form. So I'm going to point that out, but let me show you what that looks like. So on my calculator, I'm entering 19 divided by 23. And then I'm going to take the inverse sine of that. And so when I do the inverse sine of that, I get, we'll say approximately 55.698847 and some more decimals on and on and on. So the problem here is that they don't ask for the decimal form of the angle. They want the degrees and the minutes. So this part here, let's see if I can do this. This part here is degrees. And this is degrees also, but it's a portion of a degree. It's less than a degree. It's in the hundredths of a degree. So I can then say that my angle is going to be 55 degrees, and I want to figure out 0.698847, et cetera, how many minutes is that portion? And so I'm going to just ignore the, I'm going to take this decimal part. I'm going to do it on a calculator, but I'll show you what I'm doing here. So I'm going to take the portion that's not a degree, 6988847. I'm just going to take all of that decimal stuff on the calculator. And this is a part of a degree. And then I'm going to multiply or do something to this to convert this into minutes. So what we know is that each degree is worth 60 minutes. And so this part of a degree, to find out how many minutes that is, I would multiply that by 60. If I had 2 degrees, 2 times 60 would be 120 minutes. If I have 0.5 of a degree, half a degree, and I multiply that by 60, then I'll get 30 minutes. So whatever the decimal portion is that's there, if I multiply that by 60, I'll know how many minutes that is. And so I'm doing this on my calculator now. I'm taking that and I'm multiplying it by 60. And it's telling me that I then get that this product here is 41.930, et cetera. And that's how many minutes that portion of a degree translated to. And now I'm supposed to round to the nearest minute. So I'm going to call that 42 and say that this would be 55 degrees. Whoops, wrong symbol. And 42 minutes. So let me pause there because I think that conversion might be a little challenging for people. Now, of course, you could just click on view an example and they'll do a similar problem and go step by step to show you what these steps were. But nonetheless, here's how I'm trying to demonstrate that. Are there any questions about how I got angle A to the nearest degree in minute? All right, so let's put that in, 55.42. So I'm going to go here and 55 and go there and go 42. All right, so that's A. And now, there we go. So again, now I've got my triangle here. Changed colors because I didn't go back. And so we know this is C is 90 degrees. We know that that was 23. We know that was 19. B was, this is B, this is A. B was approximately equal to 13. I entered that in. And now we have A is 55 degrees and 42 minutes. Right, so now we want to find angle B. So the simplest thing is that those two have to add up to 90. So if I subtract my thing I just got from 90, I should be able to get angle B. Now we could also do the trig function thing that I just did to try to confirm that. In this case, we would be using the fact that sine B is equal, cosine of B is equal to 19/23. So we could solve for angle B by using that cosine of B is equal to adjacent over hypotenuse, and then do what we just did, where we do the inverse cosine of 19/23 and then convert it. But we could also use the angle and recognize that 90 degrees minus 55 degrees and 42 minutes should give us angle B approximated already to the nearest minute. Questions about those two different approaches to get the final angle here? All right, so if I do that out of 90, what would we get? 35, but then it's 34 and what, 18 minutes left over? So this is 89 minutes and, I'm sorry, degrees and 60 minutes is 90 minutes. I'm turning one of the degrees into 60 minutes so I can make change, kind of like making change for $1 or borrowing. And then I'm going to subtract 55 and 42. And so that's going to give me 34/18. Questions about how I got angle B there? Well, I've got it on the screen here.
Yes, if I could ask, how did we get the, did we subtract both the 55 and the 42 from the 90?
Yeah, so 55 degrees, 42 minutes is a single angle measurement. That's angle A. And we know that angles A and B add up to 90. So if I subtract A from 90, I get angle B. Does that make sense?
Wait, if you subtract 80 from 90?
Yeah, so when I'm doing this subtraction, when I have 90 degrees and no minutes, and I need to subtract some degrees and minutes, I'm basically borrowing one of my degrees and converting it into minutes. I'm making change.
Okay.
Like if I subtract $4.75 from $5, well, how do you do that? You basically say this is $4.100. You borrow one of the dollars so that you can subtract. That's like with subtraction, you do borrowing. But now 1 degree isn't worth 100 minutes, it's only worth 60 minutes. So I converted 90 degrees into 89 degrees and 60 minutes so that I could have some minutes to subtract the 42 minutes from. And then I carried out the subtraction. Does that make sense?
Yeah, that makes perfect sense.
Yeah, now if you have this on a calculator, if you have a calculator that has degrees in minutes, it'll do that automatically for you. But a lot of the quick and easy calculators don't. And so if we have this level of understanding, we could do this by ourselves, or we could follow the other process that didn't involve any of that and do what I did to get the first angle.
Okay.
Great question.
All right. Thank you.
Other questions about any part of this where I lost you, if I should explain it better or elaborate? All right, so for this one, we got 34/18. Let's see if I made a mistake somewhere by putting these in and seeing if I'm right or not. 34/18. All right, seems happy with all those, which is good. Get my point on, of course, it just practice problems, but that's the idea. Okay, so we solved a couple of triangles. So now let's, that was number 10. Maybe we will move on and try like number 15. Just going up by 5s here. Yeah, we get a little picture. So now we're into a word problem where there's a situation, but they've done a nice thing here for us that they've drawn enough of the picture for us so that we can kind of see right away that there's a triangle in there. So let's have something to work with here. A 13.5 meter fire truck ladder is leaning against a wall. So they've labeled that here. And so that means that's this ladder here, right there. There's the 13.5 meters. Find the distance D, and they have a D in our picture. The ladder goes up the wall above the fire truck. So that's this distance here. And they've kind of helped us by labeling that with a D there. But we can also see that's the side of the triangle. We're supposed to find D. If the ladder makes an angle of 23 degrees and 21 minutes. Let's see if I can just make this a little bigger for us. Keep the problem there. Okay. So they're telling us this angle here, and we do have a right triangle here. And so we want to find D compared to the angle they gave us. D is the opposite angle. And we know the hypotenuse. And so opposite relating to hypotenuse is sine. So I would know then that the sine of 23 degrees, 21 minutes is equal to the opposite, which is D, divided by the hypotenuse, which is 13.5 meters. And then I would solve that for D. And that would answer the question. So let's pause. There's questions about how I came to this equation to solve, but that's the entire problem. We solve that and then we're done. Questions about how I came up with that? All right, so before I type anything in a calculator, and then I can just do it all at once, to solve for D, it's divided by 13.5, so I would multiply by 13.5 on both sides. And these would cancel. And so then I'm going to get the D is equal to 13.5 times the sine of 23 degrees, 21 minutes. And so again, dealing with these minutes and getting it into a decimal that I could use on a calculator that doesn't have angle degrees in minutes, this would be 23 degrees plus 21 over 60 degrees as a decimal, because each minute is 1/60th of a degree, and I have 21 minutes, so that's 21/60ths of a degree. And so if I just do that separately on a calculator, even though I would just type it in all together, but if I do 21 divided by 60, and that should come out kind of nice, I get 0.35. So this is the same as 23.0, I'm sorry, no, 0.35 degrees in a decimal form for the calculator. All right, so I take that angle, 23.35 degrees, and I take the sine of that angle, and I multiply that by 13.5. And my calculator is giving me 5.35 something. So I'm getting 5.35068, and more decimals if I need. And it says type an integer or a decimal, round to the nearest hundredth. So the nearest hundredth is where the 5 is, and to the right of the 5 is a 0. So I'm going to say that the answer I want to put in is 5.35. And this is in meters because our length of measurement was in meters here. Questions about how I got this answer before I put it in and see if I'm right? Or maybe somebody sees a mistake and they want to correct me.
So, Professor, you put sine 23 degree 21, like put that into that convert that into number by calculator and multiply with the 13.5, right?
Yeah, exactly. So you might have a calculator where you can just put in 23 degrees and 21 minutes, like the TI, Texas Instruments and stuff, they can do that. But like, I don't see how to do that on a Windows or Desmos calculator. They all work with decimal degrees. So here's how I converted, degrees and minutes into a decimal degree measurement. And then either 23.35 degrees or 23 degrees, 21 minutes, either one of those, you take the sine of that and then multiply by 13.5. And that's how I got this long decimal, which I then rounded off there.
Okay.
Does that make sense?
Yes.
Okay. Other questions about what happened here? Anything I should explain better or elaborate on? All right, let's see if I'm right. So 5.35 is what I got here. I put that in 5.35, and they've already put meters there, so I can just check that. They like it. That's good. Didn't make a mistake somewhere. All right, so that was problem number 15 from the practice problems. So let's skip ahead 5 more and go to 20. I think I peeked at that earlier. There we go. So here we have number 20. It says, suppose that you are headed toward a plateau 26.9 meters high. Oh, let's do a similar question. There we go. 23.5 meters high. If the angle of elevation to the top of the plateau is 30.5 degrees, how far are you from the base of the plateau? So in this case, they didn't give us a nice picture to help us. So we're going to have to try to draw a picture out of this, have to figure out what a plateau is. Again, if you really weren't following along or were confused, maybe because of some of the language, let me just remind folks, in the practice problems, I can go view an example, and then they're drawing a picture for me and showing me what to do. It is best to try to do these yourself because you're trying to develop the skills yourself. But when you're practicing, nobody's expected to be perfect when they're practicing. So that's why the assistance is there if you need it. And then after you've tried it once with some help, you could even try a similar problem and repeat the problem by yourself to make sure you got the idea. So just reminding people, view an example is a great option where if you just go through, they'll do a very similar problem for you, and then you can try it yourself. So having said that, how do we get a triangle out of this? What is this thing of a plateau? So plateaus are when you kind of have a different measurements of height that are sort of in a stair step layout with each other. So if I'm going to try to draw this, let's switch to a friendlier color. So a plateau would be you're cruising along at one height, and then there's sort of a stair step up to another height. That's the idea of a plateau. And it says we're headed toward a plateau that's 23.5 meters high. So that means this height here is 23.5 meters. And we've got a right angle here. Then it says the angle of elevation to the top of the plateau is 30.5 degrees. So that means wherever you're at, when you look up at the top of the plateau from that point, this is the angle of elevation. And so that's 30.5 degrees. And notice in this problem, they're giving their angle with decimal degrees and not with degrees and minutes, because they're going to kind of do either one on you. But in this case, this one will be easier for us because that's what the calculator likes already anyway. Okay, so that's really all they tell us. And they ask, how far are you from the base of the plateau? So the base would be where the plateau starts. That would be here. And how far are you from there? You are looking up from this point. So they want this distance here. That's the thing they want us to figure out. Questions about how I made this picture from the description of the problem? So some of the work in these word problems will be to read the description of a situation and properly reflect that in a diagram. Because once you get a triangle drawn and you fill in the parts that you know and what part is missing that you're trying to figure out, well, then it's not a word problem anymore. Then it's just a solve the triangle problem. So obviously mistakes can be made in drawing the picture or interpreting what they say. I make those kind of mistakes regularly if I don't read it carefully, and etc. And that's part of what we want to be careful about when doing these kind of problems. So again, any questions at all about how I drew out this triangle to match this situation? All right, so now how do I solve this base of the triangle here? Let me go ahead and just call it a letter. Let's say this is X. So that'll be the distance from the base of the plateau to where I was when I looked up at an angle of elevation to the top of the plateau. And so the two things that we're looking at, what we want is the adjacent side to the angle given. And what we're told, the height, is the opposite side to the angle given. So I want to use the function that relates the opposite and the adjacent, which is the tangent. So from this, I know that tan of 30.5 degrees is going to be equal to the opposite to tangent, which was 23 or is 23.5 meters, divided by the adjacent to the tangent, which is the X that we're trying to figure out. And again, I could multiply both sides by X so that the X goes over to this side and gets canceled off of that side. And then I can divide both sides by tangent, and that'll tell me that X is equal to 23.5 meters divided by tan of 30.5 degrees. And that's when I get my calculator to give me an answer. They want this rounded to 1 decimal place. So I'm going to type it on my calculator. I've got 23.5 divided by 30.5 degrees with a tangent done to that. And if I then do the division, this tells me I get 39.895 and some more decimals. And I'm supposed to round this off to 1 decimal place. So there's where 1 decimal place is. That's where the 8 is here. And the number to the right of that is a 9. So I'm going to bump up and get 39.9 if I round to 1 decimal place. Let's see if I'm right. So 39.9 is what I get. 39.9. Seem happy with that?